Hi, very warm welcome to all of you. कैसे हैं आप? उम्मीद करते हैं कि बहुत अच्छे होंगे. Okay, and how is those? I hope all are well. Okay, now I'm going to discuss here DSA in the lecture. We have already discussed in the DSA insertion of the beginning, insertion of the ending, and insertion of the position. Okay, and also discuss here some algorithm. Okay, now today we are going to discuss here with algorithm and how can delete the single linked list in the deletion at the beginning and deletion at the ending and deletion as the position according to you. Okay, no issue. We are discussing here. Firstly, you need to, if you not look in a previous class, you need to firstly look there. Okay, then it will get easily. Okay, now I'm going to discuss here next topic. Our topic is in DSA how can delete the element in the linked list. Okay, thank you. I'm going to here discuss DSA. Okay, fine. And I am going to here discuss deletion at the beginning. Delete at start, also called start. Fine, how can delete? Firstly, I make one linked list. Suppose it is our head pointer. Okay. Fine. Our node is divided into two parts. First part is storage the data and second part is storage the address. Okay. First part already discussed here, but I am saying here is stored data, here is stored address. Fine. Let me see one thing. Fine. Okay, fine. And here is stored is the head. Okay, fine. Am I right? Right. Okay. Here suppose I want to delete this node. What will we do here? I want to delete this node at the head. Okay, how can I delete? Firstly, you need to look here. I'm just create one temp node. I want to delete. I'm just create one temp node. Sorry. Temp. One temp is equal to head. Okay. And what I will write here? Firstly, I write here one create node. First, I want to delete this node is head in the deletion at the starting. So firstly, I am create one node. Node is equal to temp is equal to head. Then what will you write here? Then head is equal to temp is equal to head. Temp is equal to head. And what we will do here? Here I am doing here temp is equal to temp of next. Fine. You are looking here. Fine. This is the way to delete and I want to delete this first node. Okay. I want to delete this node and this pointer will be go to indicate this node, this pointer. Okay, then how can I write here? I'm just creating one program with the deletion at the starting. Okay, I'm just creating here program. Need to look here. Okay, first I am writing here one function void delete at deletion at the beginning. Okay, deletion at the beginning. Okay, and I am writing here node here ampersand head. Okay, ampersand here ampersand head. Fine. And I'm just here create one function to delete the node. Okay, and firstly you need to know we have some cases. What is the first base case? What is the here first base case? If your head is null, then what will you do here? It will do underflow. It's work with the underflow. Okay, we have some one condition. What will we write here? I am writing here if head is equal to null, this condition, then I am writing here cout underflow end L. Fine, and simply return here. Fine. I am just creating one node. After that I am creating one node. Okay, head node. Okay, how can I create? Just writing here node temp is equal to head. Okay, temp is equal to, sorry, I am writing here red. Okay, because we are creating node. I am creating node temp is equal to head. Okay, temp is equal to head. Then what will be here writing here? Head is equal to head of next. Head is equal to head of next. Fine, because it's I'm creating node here, temporary node. Okay, temporary node is equal to head. Then head is equal to head of next. Okay, and previously this is a point, this node. Okay, in first node, and next time what will you do here? I am pointing this node number 2. Okay, this will be indicate, and after that what will you do here? We are just free this space. We need to free this space. Free, which is name is temp. Okay, I'm just writing here free temp. Fine. Okay, fine. What will do here? Firstly you need to see one thing. And if I talk about here algo, firstly first I am creating one pointer. Okay, just like step one what I am doing here. Firstly I am create step 1 what I am doing here. Firstly I am create set ptr is equal to 10. Okay, we are creating here pointer. Okay, we are creating here temporary node. Okay, we can write here we creating create temp node. Next what will be next step? And temp head pointer head ptr indicate in first time temp. Then what we will do here? I am doing here head. I'm writing here head is equal to head of next. Okay, and next step 3, and we are creating also pointer. Okay, fine, and step 1 and step 3, and I'm writing here step 1. Okay, step, suppose 1 2 3 4. Here you check base case, first you check base case. Okay, and after that will be creating one temp pointer. Okay, and next line this will be indicate, and after that it will free the memory, space. Fine, and I'm going to here next part we will do here. Next I am going to here discuss delete at the end. Fine, similar this thing I'm creating one function similar this thing. Suppose that this is our linked list. Here suppose null value. Okay, here indicate this thing, here head, here data address. Okay, fine. Suppose here data 5 10 12. Okay, here 10 here null value. Suppose here null value. Okay, here suppose 104, here 1000, here 5 10 11. Fine, and I want to here I'm deleting here node 5, and next I'm deletion at the ending. How can delete at the end point? Okay, you need to see here how can delete. Okay, and just firstly I need to traverse this linked list. Firstly we need to traverse this linked list, because we are when we are starting when we want to delete the at the end, firstly we need to traverse this linked list, because if you are not traverse, then it will work like just like in a deletion at the beginning. Okay, it's work with the delete. Okay, firstly we need to traverse the linked list. Fine, then how can traverse? Okay, firstly I make here one function void delete at end, and I'm creating similar node, and here address of head, here address of tail. Can I write here tail? Okay, fine, and I am checking here one base condition. What will be base condition here? Can you tell me what is the base condition? What is the base condition here? Can you tell me, anyone? If I'm writing here simply base condition, if tail is equal to our data is null, then simply here what I am writing here underflow. Here writing here cout over flow end overflow end. Fine, simply return here. Close this thing. Fine, am I okay? Okay, now I'm going to create one node. I'm going to create one node in the second last. This node is the second last. I want to delete this node. Okay, I want to delete this node, and what we will do here, this pointer will be removed here, okay, and we will print, will indicate this node, okay, and it will be free. Next time we will free this space, free this space. This name, this node name is a second last, second last. Fine, you are not looking, I think, proper. This node is a second last. Fine, fine, and I am creating one node which node name is a second last. Okay, it will be create, I am creating this node, his name is a second last. Fine, I am just creating a one node. Second last is equal to tail. Fine, second last is equal to tail. Okay, am I right? Okay, right. Fine. Now I am going to use one loop. It will be traverse the linked list because I want to delete this node. Okay, I am going to take here one loop. I'm going to take here one loop. While loop, second last of next of next. Okay, of next. Can I write here, because it is going to outside, because we have one thing, while second, we can take second last. Okay, second last. Fine, second last of next not is equal to null. Fine, then our node will be null, then it will be automatically, our loop will be false. Okay, exit of the loop, outside of the loop. Okay, it will be loop will be loop does not work. Okay, fine, then I am writing here one thing, second last node. How can traverse second last is equal to second last of next. Fine, and next line what do we write here? Next line it will be traversed, the loop. Okay, and after that what we will do here, I am just here close this loop. Okay, and create one loop, one temporary node. Okay, how can create one temporary node temp second last of next. Fine, second last of next. Then what will we do here? You need to see one thing. Okay, then what we'll do here next, when we are creating the temporary node, okay, then what we'll do here? Can anyone tell me? Okay, can anyone tell me this thing? Just creating one loop. Okay, and after that will be create one node. Okay, because it is the traverse the linked list. Okay, it is a traverse the linked list. Okay, fine, then what we'll do here? Fine, then what we'll do here? Can anyone tell me? Because second last is the null. Okay, second last of next, second last of next is equal to null. Fine. Fine. I want to, then what I will do here, I want to free the temporary node. Which one will be temp? Here I am writing here one thing, free temp. Simply close the loop. Okay. What will be here algo? If I talk about the algo, step 1. Step 1. We are also check the base condition. Check the base condition. Next, step 2. Next step 2, create the second node and create the one pointer. It's denote the tail. Okay, create set ptr as the tail. Pointer as a tail. Next, step 3. Step 3. What will we write here? We need to traverse. We can say that we need to use one loop and repeat the process 3 to 4. Okay, repeat the process. Repeat the process. Okay, till 3 to 4. 3 to 4. Fine. Fine. Next what will we do? Next we will create one node, one temp node. Step 4. Create temp node. Okay, and traverse denote the null, and I'm creating here node temp is the second next. Okay, because it will traverse the second of next. Okay, here second of next. Okay, then second of next, and it's denote null value. Second next is equal to null. Fine. Then step 5. Step 5. What we'll do here? Free temp. Fine. This is your algo, and this is the also algo. Okay. Fine. I'm just writing here one deletion at the position. Okay, just writing here deletion at the position. How can delete? Delete at position. Okay, suppose I am creating one head pointer. Here I am creating node, and here null value. Here head, here data. Okay, I want to delete this pointer, this node. How can delete? Firstly, you need to traverse the linked list. Okay, here position -1. Position -1. You need to traverse this thing. Okay, then it will be this pointer will be, suppose cut this pointer and it will denote this node. Suppose this node is 0, 1, 2. I want to delete this node 1. Okay. Suppose we have some value 10, 11, 30, 0, 8, 0, 4 and null value. Fine. How can delete? How can delete this node? How can delete? Firstly, we need to check one base condition. What I am writing here base condition. I'm just writing here if. I'm just writing here position function void delete add position. Adding a simple node here head, here int position. Okay, you need to here add one thing position. If base condition. Firstly, I am writing here if head is equal to null. Then what do we write here? What do we write here? If head is equal to null. Then what do we write here? I am writing here delete at the beginning. Simply write delete at the beginning. Delete at beginning, simply pass head. Find and simply return fine. And after that I will go to there. Okay, I'm just creating one node. Which nodes is previous? This is our previous node. I want to create this node. Firstly, I'm just here writing here one thing. Here I'm creating node previous is equal to what? Previous is equal to head. Fine. And what we will do here? I will create one current position. Current with initialize with the 0. Okay, current value initialize with the 0. I'm just writing here int current position. Current position is 0. Okay, and just writing here while current position not is equal to position minus 1. Not is equal to position minus 1. You need to see here in this program. How can write? I am just writing here position minus 1. Suppose this it will be start with the 0. Here current position is 0. Okay, I want to delete according to you user according. This node is 1 and 2, 3. This node is 1 and 2, 3. And I want to delete this node number 2. Okay, then what we will do here? If our position is 2 minus 1, then what we will do here? He's doing 1. It will be denote 1. According to user, it will be 2. Okay, node number 2. And it will delete this thing. Simply. Okay. Then what we will do here? Then you need to traverse the previous thing. Prev is equal to prev of next. Okay, fine. What we'll do here? Firstly, you need to see what we'll do here. Prev is equal to prev of next. Okay. I'm just writing here current is equal to current position plus. Simply close this loop. Find current position plus. Simply close this loop. Fine. Simply close this loop. Okay. Then what we'll do here? Next thing, I'm creating one node. Which node is temp, but it is denote the previous of next. Just I'm creating one node temp previous of next. Fine, just creating one node previous of next. Okay, then what we write here? Then I'm writing here only traverse this previous node. Previous of next is equal to previous of next of next. Okay, and simply what will be free here? I am free temporary node. Suppose this is a temp node because I want to delete this node. Okay, and here when we are this pointer will be indicate this node. Okay, denote this node. Then after that it will be you need to free this space. Okay, then what would do here? I am writing here free and writing here temp. Fine, simply free and simply close this loop. Okay, then you need to write here algo. What will you write here? How can I write algo? Look in the code and write the algo simply. Firstly, I'm writing a step one. Step 1, simply check base condition. Check the base condition. Step 2, create one previous node, one prev node. Okay, prev is equal to prev of next. Prev is equal to prev of next. Here denote is the prev of next. Fine, create one previous node. Create previous node. Fine. Step 3, what will you do here? Check base condition, create previous node. You need to repeat this thing. Step 3, set current position. Set current position is equal to 0 and repeat the process 3 to 4. Fine, am I right? And step 4, what do we write here? Step 4, simply create one temporary node. You need to create one temporary node. Create temp node. Okay, create one temp node, and temp node will be traverse the previous of next. Okay, you need to traverse and simply write here traverse the prev node. Fine, traverse the previous node. And next, step 5, what I'm writing here? Step 5, what I'm writing here? Free the temporary node. Free the memory space. Memory space. Okay. So thank you for today's. Okay. And we are discussing here delete the deletion at the starting, deletion at the ending, and deletion at the position. Okay. In next lecture we'll be discuss doubly linked list. Okay. We can say that also have some parts, circular linked list, double linked list. Okay, we'll be discuss. And firstly you need to take care. You need to firstly, I'm just explain once more. Okay, just explaining once more. Fine. Okay, I'm just creating here here how can delete I'm just creating here node and just creating a function will work, okay. And here temporary node temp is equal to temp node, and head is equal to head of next, okay. Head is equal to head of next, head is equal to head of next. This line will be denote head of next, okay, fine. And here I'm just creating ending of node, okay. And you need to traverse this node, you need to traverse this node. Which one is the tail? Because here where we are getting is the null value. Suppose where we are getting the null value, we are getting a null value, null not equal to second last next of next is not equal to null. When we are getting null, then it will loop will automatically not work, okay. It will be exit outside, okay. And fine. And after that we will create one temporary node. It is a denote of second of last, second of last. We can say the last of the second, okay. And I'm just creating one node, okay. And after that creating one second of last, second of next. Sorry, here I'm writing here one thing, next, okay. Second last next is equal to null, and I am just free this temporary node, this temp node. I'm just free, okay, fine. This is I am free here, FREE, okay, FEREE, free, fine. Simply this will be I am doing here, okay. So thank you for today's if you are supporting me, I'll do best, okay. So thank you, thanks a lot, take care, bye bye.